Good afternoon, everyone, and welcome to our second session of Housing Today Live. I'm Holly Ty, Specification Editor at Assemble Media Group, and today we're going to be unpacking building services specification. In light of recent changes to building regulations and the race to net zero, it's more important than ever for professionals in the housing industry to stay up to date on best practices for specifying building services. And today we're going to be hearing from Wayne Early, Director at Bureau Happold, who's going to be exploring the regulatory landscape and how it affects the specification process for building services, as well as looking at the latest trends and innovations in sustainable design, including strategies for reducing energy use, increasing efficiency, and improving indoor air quality. Before I pass over to Wayne for his presentation, a little housekeeping from me. If you click on the resources on the left-hand side of your screen, you'll be able to download all of the slides from today's session. And at the end of the presentation, there will be time for a short Q&A. I've been sent a few questions already in advance, but please do keep sending them in. Without further ado, Wayne, I'm going to pass over to you.
Thank you very much, Holly. Let me just share this presentation.
Perfect.
Thank you. So my presentation today is about unpacking building services specification, sustainability, retrofit and regulatory reform. I'm Wayne Early from Bureau Happold Engineering. At Bureau Happold, we're an independent global practice of over 2,500 engineering professionals. We're a limited liability partnership and we're a multidiscipline engineering practice. So we do not just MEP, but civil structures and specialisms such as air quality, fire, so pretty much everything engineering related for the built environment. At Bureau Happold, we felt that if you're going to talk the talk, you need to walk the walk. So we've committed to pretty stringent practices for achieving net zero carbon ourselves as a business, and also in projects which we design. So some of the commitments which we've made are, we aim to be net zero by 2045 as a business. That's our emissions associated with actually the business itself. And then also to reduce embodied carbon in all projects we design by 50% by 2030 from a 2020 baseline, and all new build projects to be net zero carbon in operation by 2030. So some of our global commitments, we felt that it's important to be seen as a leader, and to demonstrate it is to be seen to do it yourself. We can't just be advising clients on this pathway. We need to show leadership by example. So what regulatory changes are we talking about today? Most people will be aware that we've had an overhaul of some of the building regulations recently, most notably Part L for conservation of fuel and power, and Part F for ventilation, and we've had the introduction of Part O for overheating. I'll dive into each of these each of these regulations separately to give an idea of what's changed and what's been introduced and how this is affecting what we do in building services engineering and how we specify particular systems or technologies in order to comply both with building regulations and to achieve greater energy efficiency and less carbon emissions. So we'll start with Part L. Approved document L, it's the 2021 amendments. They're now being enforced. The document itself was it came out in December 2021, and we had up until June 2022 to decide whether or not we could adopt the new regulations or the previous 2013 version. And then it was June 23 to be formally adopted. So we've now passed the deadline. This is currently enforced. The key changes to this amendment of the regulations are that there is the calculation methodology for carbon emissions in dwellings, the SAP methodology, has been tightened up. So there's been, when these regulations are applied, there's going to be an overall sort of energy efficiency increase over the 2013 regulations of approximately 31%. That would equate to 31% of carbon emission savings. And that's done through the introduction of SAP 10.2, which is the new energy performance software, which is used to measure the compliance with Part L. The new regulations have introduced minimum requirements for services, systems, and efficiencies and controls. That's been included to address the performance gap between design and operation. There's increased guidance for specific system types like district heat networks. There's a new building regulations Part L report is also required as part of the dwelling completion, which is to be signed by the SAP assessor and developer. And the scope of air tightness testing has been expanded. All dwellings on a development must now be individually tested, whereas previously it was 10% and you could apply a penalty if you didn't test all of the sites. So they're just some of the changes in the new Part L, or the Part L 2021 amendments. Approved document O, overheating. This is a new building regulation, which was again issued at the same time as Part L, December 2021. There's a couple of key requirements in Part O, which is Part O1, which is overheating mitigation, and Part O12, which is ensuring the suitability of the overheating mitigation measures. Part O11 is that all dwellings must have a reasonable provision to be made in respect of a dwelling to limit unwanted solar gains in summer and to provide adequate means to remove heat gains from the indoor environment. Account must be taken of the safety of any occupant and a reasonable enjoyment of the residents, and mechanical cooling may only be used where insufficient heat is capable of being removed from the indoor environment without it. Part O2 looks at 5 key criteria when considering overheating, and that is security, air quality, acoustics, risk from falling, and risk of entrapment. And any of the methodologies put forward for mitigating overheating must also comply with those 5 key characteristics. And there's quite prescriptive noise levels that must be achieved if you're proposing to use an openable window, and there's very prescriptive air quality measures which also must be achieved if you're going to open a window. So once the initial overheating mitigation measure is determined, it must also comply with the 5 key criteria which I've just touched upon. Finally, on the amended documents that we're going to talk about today is approved document F for ventilation. It's linked to Part O, overheating, and whichever standards ventilation requirements are the greater takes precedence. So when doing the overheating mitigation modeling, we find that there's a higher ventilation rate required. That would be the minimum required under Part F. We must comply with the higher rate, which would be Part O, or vice versa. It's also produced prescribed levels, like low noise levels for requirements. They're very descriptive. And then the minimizing pollution levels are more prescriptive than the previous Part F 2013. The ventilation rates that were in the new Part F have increased slightly on the previous version. So for just as an example, Part F 2013 was 13 litres per second per bedroom for a 1-bedroom, and it increases in steps of 4 litres per second for each additional bedroom. Part F 2021 starts at 19 litres per second for 1-bedroom and increases in steps of 6 for each additional bedroom. So there's a greater ventilation requirements required for the new Part F. Well, what does all of this mean, you might be asking? So just to give some examples, this list is not exhaustive. It was compiled relatively quickly with what we're seeing in the industry at the moment and how we're helping our clients comply with these regulations. So touching on Part L, which seems to be, well, Part L and O, as I mentioned previously, the new Part L has a tighter compliance for carbon emissions, and that's achieved by the values which are used for the notional building being tightened, for want of a better word. So the notional building in SAP now has better performing building fabric. It has the heating system is more prescriptive, running on a lower temperature. Wastewater heat recovery is applied to all showers. Photovoltaics are applied as a proportion, a percentage of the ground area, and then the thermal elements like of the fabric are also, increased U values, much better performing U values. This has resulted in the notional building in SAP being a lot more energy efficient than the actual building. So when we are actually designing an actual building, we have to ensure that we meet or exceed all of these requirements. And if we don't, you're not going to get a compliance with Part L. So looking into each of these items sort of individually, for Part L in particular, energy efficiency, because the notional building uses wastewater heat recovery, if the actual building doesn't utilize wastewater heat recovery, we're being penalized in the B-lean section when comparing our building against a notional building. So it's forcing people to consider using wastewater heat recovery. We don't have to use it, but it would mean that you would have to gain efficiencies elsewhere. And that makes it more difficult because you're putting more strain on the other passive elements of the building, i.e. the facade, or using heat recovery with ventilation, mechanical ventilation with heat recovery. Some of the technologies we're seeing coming through are using wastewater heat recovery. It was relatively niche until a few years ago, but there's quite a few products come to the market recently, which are quite innovative. The efficiency of these technologies, it's not, honestly speaking, great. It's between 35 to 45% heat recovery, but every little bit of energy that is actually recovered, it does add up. Some other technologies recently we've seen come to market are exhaust air heat pumps, whereby the ventilation to the dwelling is provided via a fairly traditional mechanical ventilation heat recovery unit. But this heat pump is an additional bolt-on, which actually extracts heat from the exhaust air before it goes to atmosphere. So it's even after it's given up its heat to the incoming air, there's still some valuable heat left in that, which can be extracted further, and then that can be used to generate domestic hot water. So these are normally compared with a buffer vessel, such as a domestic hot water cylinder, and can be very, very efficient when considering domestic hot water production. The big changes really, and people are probably aware of this, is fossil fuel heating appliances are placing a penalty when considering doing an energy calculation. The carbon emissions factors for electricity has decreased significantly in the last few years. It's gone from almost 0.519 to 0.136. And what that means is that if we use an electrical appliance as our primary heat generation source, it actually produces less carbon when in operation than an equivalent gas-fired appliance, providing the same quantity of heat. And that's also further enhanced when you use technology such as a heat pump, because the heat pump then takes 1 unit of electricity to produce up to 3 units of heat using the coefficient of absorption. So we're seeing a huge shift from traditional gas-fired boilers to heat pumps, and whether that's at an individual scale, as would be indicated in this picture, for individual dwellings, or larger commercial industrial-sized heat pumps for groups of apartments or numbers of apartments. So electricity is the big change we see. When considering Part O, there's quite a lot to take in on Part O, and the industry is still grappling with the impacts of Part O itself. The key takeaways we've seen in performing a lot of overheating analysis in the last few months is that glazing ratios have to decrease significantly from what would have been the norm up until Part O was released. we're seeing and modeling now on new schemes coming forward that we're looking at ratios of between 25 to 30%, which a couple of years ago would have been unthinkable for an architect to design to. But to get compliance now with anything greater than maybe 35%, it means that passive measures of overheating mitigation are becoming increasingly difficult, and some form of mechanical cooling would be provided, have to be provided. And this is almost counter to the intended purpose of Part O, because we don't want to be using more energy to cool a building. It's actually intended to reduce energy consumption. And one way of doing that passively is to use something like external shading. And we're seeing that a lot more now, that we're having to design in the facade, the shading elements within the facade. We reduce the glazing, target glazing, more glazing on specific orientations, and introduce external shading. And the idea is to prevent the heat from actually gaining access into the dwellings, rather than dealing with it once it has gained access in there through mechanical cooling. We're also seeing that in order to get compliance, we're having to provide enhanced ventilation rates. A lot of new builds these days, due to increasing air tightness, we have to test for air tightness. They're becoming more airtight. So we're using mechanical ventilation with heat recovery units as a method of ventilating those dwellings. Those ventilation rates are typically quite low. But when you consider overheating, if they can be boosted, so we're seeing like maybe some larger MVHR units being employed, which is providing rates in excess of what is required under Part F, but it's useful ventilation, which is offsetting overheated gains. And what we're also seeing quite a bit is new technologies which are coming in to deal with this. Technologies that using heat pump technology, which is an electric driven, and then taking the heat rejection from those heat pumps and actually using it. So there's useful heat rejection or energy recovery, shall we say. If one apartment is in cooling mode, it means that is rejecting heat to the network, which can potentially be used usefully somewhere else, and vice versa. If somewhere is heating, it's rejection cooled, which potentially can be used somewhere else. And these types of systems are becoming more prevalent, and are becoming, as the technology matures, and the supply chain is in place, the technologies are becoming cheaper. They're becoming easier to access. They're becoming more accepted by developers, by owners, operators of existing housing stock. And that's it. It was quite a quick run through what is a very changing landscape, shall we say, and it's ever evolving, considering that the Future Home Standard is also only 2 years down the tracks in 2025, which means all of this is going to be overhauled yet again. So I hope I didn't go too fast and that I helped answer some of the questions. So back to Holly.
Thank you so much, Wayne. That was a big topic and a big challenge to try and fit it in to 15 minutes. We've had quite a few questions through, so I'm going to try and whiz through them as quick as possible. Can I invite you back onto the screen, Wayne? Your camera seems...
sure.
That's okay.
Can you not see me? Sorry.
No. Not yet.
Okay, I can see myself, and not that really helps. How about now?
No. If you hover over your face, it should be able to see the settings for microphone and camera.
Yeah, it looks like it's on.
We can see you now. Thank you.
Yeah. Perfect. Okay, thank you. I'm going to start off with the first question. It's kind of a broad one, but what are the main barriers or difficulties when it comes to specifying building services in our current landscape? And I guess more importantly, how do you think we should be tackling those challenges or overcoming them?
It's a really good question, and it might sound like I'm deflecting this slightly, but it is dependent upon the client's actual aspirations and their requirements.
Yep.
Building services specifications cover such a broad range of potential solutions that the most important thing for us to do as consulting engineers is to understand what our clients' aspirations are And the aspirations of one client may not be the same as the aspirations of another client. And it's drilling down into that. It's understanding what they require and how that we actually provide that for them. There's a lot of new technology. Well, the technology itself might have been new. Heat pump technology has been around for a very, very long time, but it's not been widely used for heating applications within the UK, for instance. And it's us having an understanding of that and being able to relate that to our clients to say, look, this is the new regulations. This is how you would comply with that regulation. And we feel that this technology, when applied correctly, will aid you to comply. And it's reviewing it. It's taken a lot of work, a lot of speaking to suppliers, a lot of factory visits, a lot of site visits to see specific technologies in operation, a lot of post occupancy evaluation studies. Does it perform as intended? Suppliers do products are tested to BS or EN standards in general, but that tends to be in a test room under laboratory conditions, not necessarily in the real world. So the real, to gain a better understanding, post-occupancy evaluation, we found doing that is really, really powerful.
Talking about technologies, I know you touched briefly on kind of various heat pump technology. What are some of the kind of latest trends and innovations in sustainable design for building services that you've seen? Any products on the market that you've been particularly impressed with?
Yeah. I think the biggest trend, and this is going to sound so almost old-fashioned, is to achieve our means passively. Victorians were amazing at it, and we had high windows, sliding slash top and bottom that could achieve really good setup ventilation currents. Is to try and go back to the future, if you like. External shading, you see it on the continent a lot for overheating mitigation. Put shutters on your windows, stop the heat getting in, reduce glazing on southern facades unless you've got significant overhangs to prevent high angle summer sun. So we're seeing a huge turn towards passive design, passive house principles, if you like. So there's definitely a massive push towards that. Technology is great. We're seeing a lot of new innovative products coming to the market, which is brilliant. But our ethos is, if we can help alleviate the energy crisis through passive measures alone, it's a better solution. Some of the good stuff I've seen, I've touched upon it in the presentation, like the ambient loop system, I think is really, really good, because you're sharing energy, from one application may require heating, one may require cooling, and you're recovering that energy. That's a really good product. The exhaust air heat pumps, pretty nifty product as well. It's gaining traction, particularly given the buildings or dwellings are being constructed to be ever more airtight. So you're using that useful air, and it's important to ensure that you get the correct ventilation to maintain a healthy indoor air environment.
Touching back on your point about reducing glazing, we did have someone send a question through, Elizabeth. Should we be concerned about limiting glazing ratios in terms of daylight and the well-being of occupants linked to daylight? I imagine this is something a lot of people are thinking about, because we're kind of helping.
Absolutely. And yes, we should be concerned about it. We internally, we call it like the energy trilemma.
Yeah.
We do need to reduce glazing to prevent excess overheating.
Yeah.
However, you need to be cognizant of the daylighting issue, which Elizabeth has touched upon. And then also, when we're looking at it in winter, believe it or not, glazing is beneficial because you're getting solar gains in winter, which are offsetting against your heating. So it's a very fine balance about how much you can reduce your glazing, or to what benefit. By reducing it significantly, yes, you're preventing overheating. It does have a negative impact on daylight, and it also has a negative impact on your heating in winter. So it's finding that balance. There is the there is a standards for minimum levels of daylighting which must be achieved, and which we do adhere to. And when we do an analysis, it's that trilemma, and then to add into that as well, we need to consider acoustics, because the noise levels on the facades would dictate whether or not we can open windows, and then also air quality. So it's not just daylighting; it's daylighting, acoustics, air quality, and like I said, beneficial heat gain during winter or heat mitigation in summer. It's proven challenging. It's proven very challenging.
Yeah. In terms of indoor air quality, we did get one question sent. We had a few on indoor air quality. I'll give you them both together. What's the biggest contributor to poor indoor air quality? And another person has asked, how accurate are indoor air quality monitors? Are some better than others?
Okay, so the biggest contributors to degradation of indoor air quality are the usual suspects. You would cooking, smoking, there's gas appliances. If you've got any other gas appliances there, wood burning stoves, potentially external air, external air permeating into the dwelling. So in some quite dense urban settings, we may have to provide NOx filtration on incoming air to the mechanical ventilation system. That would be determined, planning stage. We would have air quality sensors in place over, I think it's typically a 3-month period, so that you're monitoring the air quality over a significant period. And then you've got like VOCs, volatile organic compounds, from things like furniture, from kitchen worktops, etc. They'd be the key sort of elements that you'd have to have a look at for air quality within dwellings. On the air quality sensors, I'm not an air quality expert, but I have spoken to our in-house air quality expert or environmental expert, and he's advised me that yes, there's a significant difference in sensor types, but he also cautioned that when doing air quality measurements, it's important that you understand what you're actually measuring for.
Yep.
So specific sensors will measure for specific pollutants. So for instance, you could have a carbon dioxide sensor in there, which is not necessarily going to tell you what the carbon monoxide is, or what your nitrous oxide or NOx levels are. So it's important that you understand what you want to measure when selecting in air quality sensors.
Perfect. I think we've got a few minutes for one more question. When retrofitting an existing residential building, what are the easiest changes to make regarding building services in order to meet sustainability targets? I feel like you've touched on most of that, but the same person also asked, if installing a heat pump in an existing residential building, what site conditions / preconditions are needed?
Okay, good questions. To answer the first one, I would say insulation.
Yeah,
It's the obvious answer. If your home is not very well insulated, have a look at what you could potentially insulate. There's some very easy wins with insulation, attic being the obvious one. If you've got raised floors, upper ground floors, again, look at your windows. Biggest heat loss in buildings is typically around windows. You've got leaky windows, leaky doors. Adding a porch to a front door, that creates almost like an airlock, if you will. So you can open the porch door whilst your main door remains shut the outside one, open the inside one. A lot of heat is lost through doors like that. There's some very simple, relatively cheap fixes that anybody can make. You've seen the ads on TV. Look at your room temperature sensors, turn it down by a couple of degrees. Again, look at your boiler flow and return temperatures to your radiator circuit. A lot of people probably don't do that. You can decrease your flow temperature. If you've got a condensing boiler, that means your efficiency increases because you're actually benefiting from the condensing cycle when your boiler is in operation. Again, really, really easy, really simple things to do. To answer the heat pump question, have a look at the key thing that people need to understand is that heat pumps operate at slightly lower temperatures than boilers. If you have a combination boiler, you can't just swap out a heat pump for a combination boiler. You're going to need to install a domestic hot water cylinder. You're going to need to have storage of domestic hot water, because a heat pump cannot produce domestic hot water instantaneously. There is industrial heat pumps which will do this, but we're talking about applications like hospitals or hotels maybe. For a domestic heat pump, you're going to need a new hot water cylinder if you don't already have one. You'll also need to consider the temperatures are slightly lower than what you would expect for a boiler, and that means that your radiators may have to get slightly larger, because obviously your radiators are admitting heat into the space, and if the temperature differential across your radiators is lower because of a heat pump, it means that the radiator itself has to get slightly bigger to compensate for that. Most domestic heat pumps are single phase. You shouldn't have to get your electrical supply updated, but it is worth checking with your electricity supplier that the capacity of the supply to your house is sufficient to accommodate a heat pump.
Brilliant. Thank you very much. That 30 minutes went way too fast. Wayne has kindly agreed to answer some additional questions. We're going to do a little extended Q&A. So if you've got any burning questions, please do send them in. And I'm sorry if we didn't get to your questions. Wayne, thank you. Thank you for your time. Thank you for your expertise. I just want to quickly flag that this session and all our other sessions for Housing Today Live are available on demand for 12 months via the same link that you joined by today. So if you want to rewatch or share, then please do. Thank you to everyone as well who tuned in. I hope you'll have a lovely afternoon.
Thank you.